So in this lesson, we're working through a few examples looking at sets and Venn diagrams. So example 1 is pretty straightforward. We've got a universal set. They've used a slightly different symbol. We'll still use our omega. They want you to find the union of A and B and illustrate on a Venn diagram. We'll start by looking at the intersection as well. So the intersection between A and B. So let's look for values that exist in both. So in A, there's 1 and 1. We've got 2 and 2, and then there's no others. So the intersection between A and B is 1 and 2. The union between A and B will be the values that exist in either one or the other. So we have 1 and 2, 3, 9, and 10. So these values are the union of A and B. To put these into a Venn diagram, we can start by drawing the space. Our omega represents a universal set. We have A and B, and they must overlap as there's an intersection between them, which includes the values 1 and 2. Now, the values that exist in A but not in B are 3, and the values that exist in B but not in A are 9 and 10. So within these two circles, we should have all the values that are A or B or A union B. So we've got 1, 2, 3, 9, and 10. Now the remaining values that exist outside of sets A and B are going to be 4, 5, 6, 7, and 8. So these values, 4, 5, 6, 7, and 8 will be not A and not B. Alright, so that concludes the question. All we had to do was find A or B, which is this here, and then illustrate on a Venn diagram. You can see that we've done that. If we wanted to draw a Venn diagram with the cardinalities, so just looking at the numbers in each of those sets, then we can say that the set contains 10 values. There's 2 that are the intersection between A and B, 1 that is A but not B, 2 that are B but not A, and therefore the union of A and B will have 5 values, which means that there's 5 values remaining as part of the universal set, but not parts of the subset A or B. Okay, so that concludes the first example. We'll now move down and look at a second example. So in this example, we've got the universal set being prime numbers that are less than 40, where A is 3, 5, 7, 11, and B is 3, 7, 29, and 37. So first thing we need to do is define this universal set. So our prime numbers, first one is 2, 3, 5, 7, not 9, 11, 13, not 15, 17, 19, not 21, 23, not 25, not 27, 29, 31, not 33, not 35, 37, and not 39. Okay, so there's our universal set. We know what A and B are already. We want to look at the set A and B, or A intersection B, and we want to illustrate on a Venn diagram. So if we look at A intersection B, we're looking for the values that exist in each. So 3 exists in each, 7 exists in each, and that's it. So 3 and 7 is our intersection. Our union will be 3, 5, 7, 11, 29, and 37. So the values that exist in either or. And from this, we can draw a Venn diagram. So we've got A, we've got set B, and the intersection includes 3 and 7. the values in A that don't exist in B are 5 and 11, and the values in B that don't exist in A are 29 and 37, which means we've got quite a few left over that are not A and not B. So we have 2, 13, 17, 19, 23, 31. And so these ones go down here. We've got 2, 13, 17, 19, 23, and 31. Then if we look at a Venn diagram with the cardinalities, we have 2, 2, and 2. There's 12 in total in the universal set. So that means there's 6 that remain outside. So that concludes the second example. Again, it's just a matter of defining the correct sets and being able to construct that into a Venn diagram. When we look at example 3, we've again got a defined universal set, the values 1 to 10, where A is odd numbers, and that's defined for us. B is multiples of 3, and that's defined for us. And we want to show these sets on a Venn diagram first. So part A, we'll probably start with looking at A and B. So the intersection is 3 and 9. The union is 1, 3, 5, 6, 7, and 9. And the values that exist outside of the subsets A and B, but still part of the universal set, are 2, 4, and 8, and 10. So when we draw our Venn diagram then, we have 3 and 9. We have 6 over as part of B. And as part of A, we have 1 and 5 and 7. And then we have 2, 4, 8, and 10 on the outside. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We still have all the values existing within that Venn diagram. For part B, it says, use the diagram to list the following sets. So if we're looking at not A is all the values that don't exist inside A. So you can see here that this is A. So everything that is not A is outside of that. So that means we have 2, 4, 6, 8, and 10, which makes sense because A is odd numbers and therefore not A must be even numbers. We're looking for now not B. So this is B, and not B is everything that's outside of that. So we have 1, 2, 4, 5, 7, 8, and 10. And again, that makes sense because B is multiples of 3. So this is everything that is not multiples of 3. We want to state A or B, and we've already done that, but we'll do it again. So A or B is everything within the two circles, so everything that's included in A or B. So that means we have 1, 3, 5, 6, 7, and 9. The complement of A or B, which is A or B not. So that means now instead of looking at what's inside, we're looking at what is outside. So that means we have a set that includes 2, 4, 8, and 10. And then finally the last one is not A and not B, which is the same as A or B not. All right. So that concludes the third example. Again, it's just further practice looking at the specifically defined subsets within the original universal set. All right, so our last example, we've got 3 sets this time. So I'm going to say the universal set is the numbers between 15 and 30 are the numbers between 15 and 30 that are divisible by 2. So that will be 16, 18, 20, 22, 24, 26, 28, and 30. S is the numbers between 15 and 30 inclusive that are divisible by 3. Just in case you're not sure, inclusive means that it includes 15 and 30 as part of the sets. So S will be 15, 18, 21, 24, 27, and 30. And T are the numbers between 15 and 30 inclusive that are divisible by 5. So that will be 15, 20, 25, and 30. So it wants us to construct a Venn diagram to represent R, S, and T. Now we should look first to see if there's an intersection between all of them. So if we say R and S and T, are there any values that exist in all three? So we'll color them in with green. So we can see only 30 exists in all three. Just check that again. Yes, only 30 exists within all three. So therefore, the triple intersection is 30. The intersections between R and S, which we'll put in yellow, are 18, 24. So we've got 18 and 24. The intersections between R and T, which we'll put in blue, are 20 and 30. So I did miss out here, 30. This is 20 and 30. The intersections between S and T are, which we'll put in purple, will be 15 and 30. Now that we have all of this, we should be able to construct a Venn diagram. So this one's a little bit harder to construct. We'll have 1, 2, and 3. Now the reason there's so many overlaps is because we've already determined that there's intersections between each of these things. So if we start by filling in the intersections, obviously 30 is the triple intersection. And let's define this. This is R, S, and T. So in R and S, we have 18 and 24 as well. So 18, 24, and 30 is the intersection between those two. Between R and T is 20 and 30. So there's 20 and 30. And between S and T, we've got 15 and 30. So 15 and 30. So we have our intersections there. Finally, we can now fill in the remainder for each. So in R, we also have 16, 22, 26, and 28. In S, we also have 21 and 27. And in T, we also have 25. Now, there are some values that exist outside this set, so it will be useful for us to write down what R or S or T is equal to. So this is also what part B is, but we want to use this to finish drawing the Venn diagram anyway. So 15, 16, there's no 17, but 18. There's no 19, but there's 20. There's 21, 22, no 23, but there's 24, 25, 26, 27, 28, and 30. Okay, so there's our union. And if we wanted to define then not R, not S, and not T, then it will include all the leftover values. So we have 17, 19, 23, and 29. So these values on the outside are 17, 19, 23, and 29. Okay, so here's part A and part B. Here's what we've already defined. the union of all three, and that's 15, 16, 18, 20, 21, 22, 24, 25, 26, 27, 28, and 30. The other way to look at that is it's everything within the three combined. Okay, so hopefully that helps with understanding. Knowing this well will lead to better application of the inclusion-exclusion principle that we'll talk about next lesson. Thank you for listening.